All right, assignment 6.2, trigonometry, inverse trigonometry. When we inverse trigonometry, we're finding the angle that goes with this. So at what angle is the y-coordinate root 3 over 2? So that answer is pi over 3. At what angle is tangent negative 1? We also have to be aware of restrictions when things are negative. If this value is positive, it's always in quadrant 1. If it's negative, it could be in quadrant 4, it could be in quadrant 2. Tangent is in quadrant 4 as a negative angle. So that angle is negative pi over 4 at 45 degrees. Tangent's y over x. That gives you that answer. Cosine is the x-coordinate. This is going to be in quadrant number 2. And you look, what angle is that true for? And that answer is 2 pi over 3. Tangent's a little trickier always. It's y over x. So you're thinking of root 3 over 2 over 1/2. So where is that the case where it's positive? And that's pi over 6. Oh, the y. That's pi over 3. For number 5, can you solve an equation? So we need to understand arctangent has this angle at what? So again, we're looking at y over x, and so that answer would be negative 1, and then solve it. So I'd add 1 and add x, and x would equal 4. For number 6, arc cosine x squared minus 2 equals pi. So negative 1 would give me the answer pi, and then solve it. So the answer is positive or negative 1. Number 7, cosine y. Y equals arc sine negative 4 over 5. For this one, I'm going to draw a triangle. So for sine, this is going to be in quadrant number 4. And so think of it as opposite over hypotenuse. This is a 3, 4, 5 triangle, or you can use the Pythagorean theorem. So cosine y then would equal 3 over 5. Because it's adjacent over hypotenuse. Find sine x of x equals arc tan 3. So this is in quadrant number 1. Opposite over adjacent. 9 plus 1 is the square root of 10. And what are we looking for again? Sine. So sine would be opposite over hypotenuse. And you can leave it as that answer. Number 9. All right, now we get to differentiate. So what are some things I remind myself? So when you're taking the derivative of arctangent, arcsine, arccosine, it's a fraction. Start with the denominator. And we have a 2 in front. So we'll put the 2 in front, then that. Now, it's going to be 1 plus whatever's there, we square it, and then the derivative of that goes in the numerator. So let's practice that technique again. How about arc? Sine. So the derivative is a fraction. For sine and cosine, it's a square root. It's 1 subtract. And then whatever there goes inside the parentheses squared. And then the derivative of that goes in the numerator. Number 11. You just have to be a rule follower. Some have an easier time than others. Arcsine is a fraction. It's a square root. It's 1 subtract. And then what I see is squared, and the derivative of that, e to the negative y, and then it has its own hook up there, negative 1. That's the numerator. Number 12. Arctan t to the 3 over 2. So when I take the derivative, I know it's a fraction. It's going to be 1 plus whatever this is squared. And then the derivative of that goes in the numerator. Number 6. I can't even count. Number 13. This is the product rule. That's the first times the derivative of the second. So it's 1 subtract x squared. And then the derivative of that is 1. But because it's cosine, it's going to be negative 1 plus the second arc cosine times the derivative of the first. (14) Theta is a variable just like x or y. It's okay. All right, arctangent is a fraction. It's 1 plus whatever you see squared, and then the derivative of that goes in the numerator. So that theta could also be below, and it's 1 over that. All good. 15. It's better to be a good rule follower than trying to figure out algebra at the end. The only reason I try to figure out algebra is to match something in multiple choice. All right, this is called a definite integral. That means there's an extra step at the end of substitution. So how do I work backwards here? What does this remind me of? So I see a fraction, I see square root 1 minus. To me, clearly it feels like sine. And so I take 4x squared, and I square root it, and I get 2x. If you think of your formula, that would be what u is. A is the square root of 1, which is 1. And then the formula goes arc sine u over a, and a is 1. And then we plug in. Oh, I forgot a bit of a hook here. So what's the derivative of 2x is 2. So this needs to be 2, which means I need a 1/2 in front. I'm going to plug 1/4 in. 2 times a quarter is a half. I'm going to plug 0 in. The angle where the y coordinate is 1/2 is pi over 6. The angle here where it's 0 is 0. So this answer is pi over 12. Number 16. So think what form it's in, and then we're going to go from there. So if I see a fraction, I can tell if I take the derivative of this, it doesn't match. So it's not a logarithm. I see a constant up there. So if I take the square root of that, that's what u is. So u is the square root of 9x squared. A is the square root of 25. And then the derivative of this is 3. So I'm going to rewrite it the way it needs to be written. And then what was it before over what it became? So I needed 2/3 in front. Now I got to be a rule follower. So even me, sometimes if I forget, I'm going to go back and look at the book. What's the rule again for this? And so the rule is it's 1 over a, so it'd be 1 over 5, arctangent, and then it's u over a, which is that, 3x over 5, and then it's from 0 to 5 over 3. Oh, and there's a 2/3 still in front that I should have started with. There it is. So this is 2 over 15. I'm just going to put that in front. I plug in 5 over 3 and 3 over 5. That leaves me with arctangent 1. I plug in 0, and that leaves me with 0. So the value of arctangent at 1 is pi over 4. The value of arctangent at 0 is 0. And so there's your answer. So if you can reduce it down if you want, but it's pi over 30. So 2 goes into 4 twice, and 15 times 2, it's pi over 30. Number 17. In number 17, we're integrating from 0 to 1. And so the form I'm looking for is not arcsine or any of that. So when I look at this for number 17, it doesn't fit into the form that I'm looking for. So I'm going to change it. So when I look at the power terms, if they're even or if one is a little bigger than the other, I can do long division to rewrite this. So I'm going to do long division to rewrite it. X squared divided by x is x. I'm going to distribute and subtract to find the remainder. And then I'm going to come back here and I'm going to write it as 2 questions. So first of all, my answer is x, and then the remainder is negative. So I'm going to subtract, and then it's the remainder over x plus 1. Oh, I could have actually done further, because now I'd have to do long division again. Let me rewrite this again. So here's the remainder. Negative x divided by x is negative 1. So I could have gone one more step. This is fine. I'm just going to rewrite it at the end. And now the remainder, when you subtract a negative, is positive 1. So we still have this and this. And we now have the remainder as something we can work with, which is 1 over x plus 1. So I'm just going to integrate each one separately and then go 0 to 1. So x is x squared over 2. 1 is just x. And this is a logarithm, which is x plus 1. And again, we're integrating from 0 to 1. We're going to plug 1 in, and we get 1/2 take away 1. 1 plus 1 is 2. If I plug 0 in, I get 0. I get 0. Ln 1 is 0. So there's your answer. 1/2 take away 1 is negative 1/2 plus ln 2. And it's done. Number 18. This one does feel like inverse trigonometry, and it feels like tangent. So if I said, hey, what does a equal? It would be the square root of 2. What does u equal? The square root of a square just leaves me with 2t plus 1, and then the derivative of u, or u prime, is 2. And so I'm going to rewrite this with 2, and then what was it before over what it became? I need a 4 in front. Now I need to be a rule follower. It starts with a 4, and then it's 1 over a, arctan, and then it's u over a, plus c. Looks complicated, but just follow the rules. Number 19. We're going to integrate w squared, the square root of 4 subtract w to the 6th. So when I look at this, I see arc sine because of the square root and subtracting, and then I want to see if I can make this work. So u is the square root of w to the 6th. When you square root an exponent, you divide it by 2. So it's really w to the 3. When I take the derivative of that, it's 3w squared. A is the square root of 4, which is 2. And now I'm going to write it how it needs to be written. This is my numerator. And then what it was over what it became, I need 1/3. So my answer is going to start with 1/3. Arc sine does not start with a fraction in front. It's just right into arc sine. And it's u over a, which is w cubed over 2, and then plus c. Number 20. We're going to integrate. So I'm going to tell you what I see. So this is not in the form of arc sine, but I do see that this, the derivative of ln x, is 1 over x. So I'm going to write it calculus friendly. Interesting. All right, I'm going to change my mind. So when I take the derivative of this, it'll be 2, and it would end up being 2 ln x with a hook of 1 over x. This does not help me in the numerator. I only have 1 over x. So when I look at it more carefully, it is in the form of sine, and it's okay to go in a different direction and then rethink it. So u, in that case, would be ln x, and the derivative of u is 1 over x. A would be the square root of 16. And I want you to notice we already have 1 over x as the hook. So this is ready to go. And the answer is arc sine u over a plus c. Number 21. It's okay to go in a different direction, look at it, and then think it's not working, I'm not giving up. What's a different direction I can go? That seems like a really good life skill. Arc tangent theta 1 plus theta squared. And what would I do here? All right, so I'm going to make it calculus friendly. Notice I wrote this as 1 over this. The derivative of this is 1 over 1 plus theta squared. That's what the derivative of this is. So the hook is there. So I just need to unhook and do the power rule. That means I'm just going to add 1 to the exponent and then divide, or the reciprocal, and then plus c. 22. That's not 22. 22. So when I see a fraction, you go through options. And so whether it's a logarithm option or inverse trigonometry option, or is it calculus friendly and have to do the power rule, you're just going to have to go through options and what you see. The easiest option to look at is a logarithm. What's the derivative of the denominator? Are they like terms? Yes. And so that's what I need to do. Oh, I need integration sign. And so it should be 2x. And what it was over what it became. And so the answer is 5 over 2. It's a logarithm. X squared plus 1 plus c. 23. we're going to integrate 5x squared over x squared plus 1. So if I think of the different options, arc sine is off. Logarithm right now wouldn't match. And so I see the power terms have the same degree, or if this was 1 degree more, it would still be the same. It would be long division to begin with. So when the numerator is more powerful with its degree, we often have to do long division. So 5 divided by 1, and then multiply, and then the remainder. So the remainder is -5. So I'm going to start with 5, and the remainder is going to be written as a fraction. Now, if I look here again, the derivative of this is not going to match. This is not a logarithm. This is actually arctangent that's left, where u is the square root of x squared, a is the square root of 1, and then the derivative of x is 1. So this numerator should really be 1, which makes this in front a 5, and now I can actually integrate it. So the integration of 5 is 5x. The integration here, minus 5, is arctan. And we need a fraction in front, u over a, or sorry, 1 over 1 I mean. So it's 1 over a. Well, 1 over 1 is 1, so I don't need the 1 in front. So it's just 5. And then inside would be u over a, which is x over 1, which is just x, and then plus c. (24). So when I look at the form of it, arc sine to me is one of the easier ones to see, where it's square root, it's subtracting. If I make it and so on in terms of what it is. And so first of all, I'm going to try that. So u in this case would be the square root of sine squared, which is sine. The derivative of that is cosine. And then a would be the square root of 25, which is 5. And if you look carefully, the hook is what it should be. So I don't need to do anything else. The rule for sine is write down arc sine, and then it's u over a. (25). I'm going to integrate e to the negative 2v, 3 plus e to the negative 4v. It feels like it could be arctangent, and we're going to see. So u is e to the negative 4v. The derivative is e to the negative 4v times negative 4, and then a would be the square root of 3. So that's not like terms with the numerator. Oh, wait a second. It might be if I did this right. So I need to take the square root of this. Square root means the same as the exponent 1/2. So when you combine it together, this is actually negative 2v. This is negative 2v. And the hook is negative 2. Ha! Well, now it definitely matches, but it needs a negative 2, which means I need a negative 1/2. So we're going to start with negative 1/2. And then I'm going to go 1 over a, and then arctan, and then u over a, plus c. (26). Oops. So cube root I don't have anything for cube root. I got to make it calculus friendly. And then what I feel I need to do at this point is to do use substitutions. Let me just check to make sure I'm in the right direction. The derivative of this won't match this, so I'm going to let u equal 3x plus 1. I'm going to solve for x. I'm going to subtract 1 and divide everything by 3. And then when I take the derivative, this is what I have. So these are the substitutions I'm going to use. So x is u over 3 minus 1 over 3. 3x plus 1 is now just u. And then dx is 1/3 du. And I'll put the 1/3 in front. In fact, I might make my life easier by factoring out a 2/3. So I factor out a 2/3 and then put that, and then I got 2/9 in front. And then I can just distribute. So when I multiply, I add the exponents. And then at this step, I can do the power rule. So I'm going to add 1 to the exponent, 2 plus 3, and then do the reciprocal. I'm going to add 1, that's 2/3, and then the reciprocal. And then I got to put x back in. So u is equal to 3x plus 1. That could have been worse. And it's done. Number 27. Let's turn the page. All right, these are some different ones. Do not use a calculator. What? I won't use a calculator. You get all this graphing paper. Let me find some white paper here. Oh, next, 27. Find the average value. Average value is an integration question. And we're integrating 6 over 1 plus 2x squared. And then the bounds go from 0 to 1/2. And then I divide, I could have written out a little bit better, by the difference of the bounds. So there you go. It's an integration question. Divide by the difference of the bounds. 1/2, take away 0. When I divide by 1/2, it's really times 2. And then what does this look like? And so I hope what it looks like is arctangent. So I'm going to write down u is the square root. They cross out as 2x. The derivative of u is 2. And a is the square root of 1, which is 1. So this needs to be the numerator. And what it was over what it became, I need a 3 in front, so now that's 6. And now I can do this. So it starts with 1 over a. Well, 1 over 1 is 1. Then arctan, and that's u over a. So 2x over 1, which is 2x. And then I'm integrating from 0 to 1/2. First, I'm going to plug in 1/2. 2 times 1/2 is just 1. Subtract, plug in 0. The value of arctangent at 1 is pi over 4. And the value of arctangent at 0 is 0. So if you reduce it down, it's 3 pi over 2. And that's the average value of that function. 28. Find the area. That's an integration question. Of that function from 0 to 1.5. So like, what would I do to get a sense of this? I mean, if you plug in 0, the answer is 3 divided by 3, which is 1. So 0 gives you the answer 1. And then if you plug in 1.5, it's going to get smaller by something. And so whatever this function is, it's important to realize that when you go top, subtract, bottom, in terms of that, it's just the function divided by that. So to find area, we're going to integrate from 0 to 1.5. It's the function and that's what finds the area. So what's above and what's below? There's only one function. To find the area of one function, you just integrate that one function. If we had two functions, we'd have to see which was above and which was below. All right, this looks like sine. U is the square root of x squared. The derivative of u is 1, and a is the square root of 9, which is 3. This number here should be 1, which makes this a 3 in front. And now we can get started. So it's 3 arc sine u over a. And it goes from 0 to 1.5. I'm going to remind myself that 1.5 is 3 over 2. So that when I plug in here, 3 over 2 times 3, the 3's cross out and leave me with 1/2. Subtract, plug in 0. Arc sine at 0 is 0. And at what angle is the y coordinate 1/2? And then you have your answer. Reduce it down, and the answer is pi over 2 is the area there. Number 29. Four cosine x sine y minus root 6 equals 0. Find the derivative there. So this is going to be implicitly with the product rule. So we have the first times the derivative of the second, and we need a y prime, minus the second times the derivative of the first. The derivative of root x is 0. And now we need to get y prime by itself. So a negative times a negative. Oh, this should be a plus. Plus the second times. All right. So a negative times a positive is negative. So I'm going to rearrange this equation by adding it to the other side. Oop, there's a 4 there. So I'm going to add this to the other side. This stayed the same. And then I'm going to divide to get y prime by itself. Notice the 4's will divide out when you do that. And then I have a point to plug in, which is at pi over 6 and pi over 4. So this is the x coordinate and this is the y coordinate. So the derivative at pi over 6 and pi over 4 equals, so the value of sine at pi over 4, let's just write it in. Sine of pi over 4, the sine of pi over 6, the cosine of pi, same thing, right? Pi over 4, the cosine of pi over 6. So at pi over 4, they actually have the same value, so they can divide out. At pi over 6, it's 1/2, and then root 3 over 2. So this answer is 1 over root 3. Number 30. Integrate secant squared 2x over the square root of tangent 2x dx. So I'm going to write this calculus friendly. The derivative of tangent is secant squared 2x, but it needs a 2 for a hook, so it needs a 1/2 in front. Then this whole hook you can ignore or have it go away. And that's just the power rule. So the power rule is add 1 to the exponent and then divide. And I just did it that way because you could actually see how the 1/2s divide out. And so it's just tangent 2x to this 1/2, or the square root of tangent 2x. 31. Integrate. I'm telling you, this comes with practice. There is no shortcut to practice to see the different ways you can integrate. When you take derivatives, it's just just follow the rule, basically. Much easier. When it's integrating, it's much more interesting because you really have to solve the puzzle of what's in front of you to try to figure this out. All right. So when I'm trying to solve this puzzle, what are the different things I'm looking at? What's the derivative? I see a fraction. Writing it calculus friendly may or not help here. The derivative of sine ET is cosine ET times the hook, which is ET, which sounds like a great movie, ET. So the hook actually is there. This is just ln. It's a logarithm, and it's done. Number 32. If you see it, it's easy. You only see things as you practice. Cotangent squared 3x dx. This is going to require a trig identity. So cotangent squared is equal to cosecant squared minus 1 the hook here is 3, so I need a 1/3, and the derivative rule is negative cotangent, 3x, and then the antiderivative of negative 1 is negative x plus c. Number 33. Use a calculator, finally. And negative 1 is the inverse. So to understand this, step number 1 is recognize that's the y value for the function. So inverse. So if I inverse that, this is the x value of the inverse, which makes it the y value. In other words, make it equal to 2 and use your calculator. So now use your calculator and solve this equation. I'm going to do it too. Menu algebra solve. And I'm going to type it in. And make sure you go comma x at the end. Okay? And I get negative 0.453. Next, I need to take the derivative at negative 0.453. Not the inverse, but this derivative at this value. So I'm going to type in. Now I'm going to do menu calculus, derivative at a point. That's number 2. And then I plug in negative 0.453. And then I plug in the square root of x cubed plus 2x plus 5. And I get 0.654. I'm going to make this really simple. As long as it's numerically equivalent, it's perfect. So we know we need to do the reciprocal. So the inverse of g at 2 then is the reciprocal of that. So I'm just going to write it like so. That is the reciprocal. And you have the answer. 34. All right, I might do it right on here. You should draw this in your notes and then draw a slope field. So x times y divided by 2. So I know that at when x is 0, it's 0. Oh, on the indicated 12 point. So when x is 0, this answer is 0. So this is going to be where the turning point could be. Could be also the end behavior. But I see what's happening. See the turning point. A horizontal tangent. And then multiply it. So like this would be negative 2 times 2 divided by 2. So that's negative 2. This would be negative 2 times 1. It's negative 2. Divided by 2 is negative 1. Not quite as steep. This would be negative a half. Not quite as steep. This one would also be the same as this one. Negative 1. This would be symmetry here. This is going to be positive a half. This will be positive 1. This will be positive 2. And this would be positive 1. All right. And then it says sketch a sculpture containing the point 0, 1. Let's do that. Where's my... Here, I'll use this color. So 0, 1. That's going to be a turning point. And then you can see what's happening. It turns this way. And it turns this way. So there's the slope. That's the graphical solution of what you did. Part B is use Euler's method. So I'm going to do that here. So Euler's method, I need the x, the y, the derivative, which is x divided by y, x times y divided by 2. And then the change in y is going to be the derivative times the change in x, which is 1. So it says start at 0, 1. If I go 0 times 1 divided by 2, the answer is 0. And then we have that times that. So that's going to give me 0. So I'm going to add 1. The y value, when you add it, stays the same. Now we're going to multiply and divide by 2. So now I take the answer 1/2 times the change in x, which is 1. And now I get the answer for 2. So I add 1/2 and I get 3 over 2. Double checking, and there you go. So that's Euler's method to find the approximate value of that. 35. The number of rabbits. Oh, I'm not done with 34. That was just B. Part C, solve the Diffie-Q. I love solving Diffie-Qs. So we're going to multiply by dx. We're going to divide by y. And then I'm going to integrate this. So this is ln y. This is just 1/2 x squared divided by 2. I'm going to write this as an exponential. 1/2 divided by 2 is just 1/4. And then instead of plus c, I'm going to go times e times to the c. Remove the bars, plus or minus. And then write down that you're changing the constant, that you have the ability to do a constant substitution to make it simpler. And then it says find it through 0, 1. So at this step, I'm going to plug in 0 for x. So if I plug in 0 for x, e to the 0 is 1, so c2 is equal to 1. So when I solve this, because the constant's 1, this is the answer. It's 1/4 e to the 1/4 x squared. D, use your solution to find the exact value when x equals 2. So when x equals 2, we plug 2 in. 2 squared is 4, and then 1/4 times 4 is 1. This is just e to the 1, and the approximate value of e is 2.7. Again, that's right. So it's about 2.7. Use your calculator. All right. On to number 35. This is our last question. No, it's not. 36s. Almost the last question. Is that any better? We're good. We're at 45 minutes. I said this before. I try to keep this to an hour or less. The number of rabbits on an island during a measured 5 period of time, this is going to be a calculator. Oh, it says do some stuff without a calculator. All right, is modeled by n at t 1000 sine 2t minus 300 cosine t plus 3000. It's easy to feel already intimidated. Don't. And it goes from 0 to 5 years. And it says use a calculator. Well, there you go. To find n at 2 and n at 4, and then specify units and round to the whole number. Now, what I'm going to do is I'm just going to define it first in my calculator to make it easier. So I'm going to remind you how you do that. I'm going to press the shaky calculator like I'm going to graph. I'm going to press tab, and then I already have something there, so I'm going to erase it. And then I'm just going to type this in, so make it easier, so I don't have to retype it in every time. So 1000, press the trig button, and then sine, and then 2x, because this doesn't like t, that's okay. Subtract 300, cosine, trig button, cosine, that's just going to be x, and then plus 3000. Just double check, we have 1000, we have 300, 2x, x plus 3000, so it looks okay. And then press enter, so it's defined. I'm not really thinking about the graph. Press the shaky calculator again, and so when it says find the value at 2, all you have to do is go F1, 2, go control enter, and it's already there, ready to go. So it's 2000 to the whole number. That would be 2,368 rabbits, because that's what we're talking about. 2,368 rabbits. And then if I did, because that's what it represents, the number of rabbits, 4, because we already did this, the work to put it in, I don't have to, I can just go F1, 4. And then 4 is 4,185 rabbits. So in year 2 or year 4, you can see how many rabbits there are, and it's increasing. B, find the derivative without a calculator. So the derivative of, the derivative here would be 1000 cosine 2t, and then it has a hook of 2, so we got to go times 2, minus 300. Now the derivative of cosine is negative sign, so we'll make this a plus, and then the derivative of 3000 is 0. So there's the derivative. C, use a calculator to find the derivative at 1. So we've already done the hard work, which is wonderful. So how would I find the derivative at 1? I would go, turn it on, I would go menu calculus, a derivative at a point, and it's just F1 at x. Control enter, and there you go, negative 579.852. Because it's a rate, you can write it with decimals at the end. And that's rabbits per year. So it's decreasing the first year. And then do the same work with 3. Honestly, you could just go back here and highlight it, press enter, and then just change that number to a 3. Control enter. And now the rate is 1,962.676. Again, that's rabbits per year. So there you go. Next. At what times during the 5 years of population was the rabbit population the greatest? So we need to take the derivative equal to 0 to begin with. So we're going to solve an equation with this. So we're going to go algebra, we're going to solve, and we're going to take the derivative. So menu, calculus, derivative. We'll use x because it's f1 at x. And we want that equal to 0, and then comma x. Oops, didn't mean that one. Comma x. And then go control enter. And so you see negative, so we're looking for the 1. Did I type something wrong? The derivative equal to 0. Let's put it in between. Let's try this. So I did that. Let's go control enter and then put it in between 0 and 5. There we go. So I put a restriction between 0 and 5 to solve it because it's trigonometry. There's an infinite number of answers. So I see now the two answers, which are 0.841. I'm going to draw a number line. So it's from 0 to 5. So I have 0.841, and the other one is 2.300. Now what I'm going to do, this is a derivative number line, is I'm going to use my calculator and evaluate at a number smaller than this to see if it's positive or negative. So if I go menu and calculus and derivative at a point, so I'm going to pick a number like 0.5. You can pick any number between there and just put in f1 at x. And then see, is the answer positive or negative? So I can see the answer is positive. Now I'm going to pick another number, so I can pick like 1. So I'm just going to go here, highlight over it, change this number to 1. That answer is negative. Then I'm going to pick another number bigger here, between here and here, like 3. And again, I just want to see if it's positive or negative. So when you look here, where would be the maximum in terms of it, and where would be the minimum between 0 and 5? Oh, is there another one that I didn't even see? Let me go back up. My answer key says I'm missing an answer. I am missing an answer. See, I have to go back up and make sure I got all the answers. There's 3.87. Well, I'm going to put that right there. 3.876. So I tried 3, so that works. So now I need to pick a number bigger than 3.8. Oops. 3.8, like 3.9 or 4. So I'm just going to put in 4. So if I put in 4, now the answer is negative again. So it increased, then it decreased, and then it increased. And the question is, the rabbit population, where was it greatest? And so the answer is going to be after the beginning of the measurement, as it increased and then decreased and then increased, that this last increase, when t equals 3.876 years, the rabbit population was the greatest. And you can tell even here, when you plug in 2 or when you plug in 4, you can tell the rabbit population is bigger here than at this. So this is like a little maximum, and then it goes way down, and then the big maximum's here. E. It says, what was the greatest number? So I'm going to plug this 3.876 into just the function, not the derivative. So I'm just going to go F1 and plug that in, 3.876. So 4,217. That was the greatest number of rabbits. F, does the function go through at least one full period cycle through the 5 years? And the answer is no. So if you think of one cycle, that's 2 pi. And 2 pi is like about a little bit bigger than 6. So 0 to 5 is not one cycle. G, what is the period of it? So 2 pi is the period. Or just over 6 years. That was a good question. I know it wasn't easy. I know that's a good place to get to. And if we're not there, we're practicing to try to get there. Number 36. This is the last question. I'm no longer teasing about that. We're almost there, under an hour, so I like that. In 1990, the population of a city was 123,000 and some. In 2000, the city was bigger than that. This is what it's following. And so we started with 123,580. We got to 152,918. And that took 10 years. From 1990 to 2000. So step 1, use your calculator and solve this equation and find the growth rate. So press menu in algebra, solve, and use the exponent 10k and then see what k equals. I'm going to do that for you. So the rate is about 0.021. I'll do it. In the mood. Here we go. So menu algebra, solve, and we put in 152,918. Oopsie. So 152,918 equals 123,580. And then E, which is on the left side of your calculator. And then I said 10K, which is fine. And then go comma K. And it's about point that. That's wonderful. And then it says, what will be the city's population in 2025? So then we're going to write this again. But now we know the rate is 0.021. From 1990 to 2025 is 35 years. And then that's what you're going to put in your calculator. So I don't need y equals. I'm not solving for any equation other than like what's already there. So just start typing 123,580. E on the left. Now I'd like you to copy this. So copy this answer. And then go Control C. And then come here and then go Control V. And I'll paste it in, and then just get rid of the k equals part, and then the full number is in there. And then I'm still going to go times, what did I say, 35? And I have to round to a whole number because it's population. So it's 260,456. And you have your answer. All right, Mr. G Math over and out. I am so proud of you. This was not a simple assignment. Working it through, doing your best. Till next time.